Okay, so chain rule. Now, in explaining the chain rule, Leibniz notation, okay, Leibniz notation splits up the outside function and the inside function. And how they do that in Leibniz notation is dy dx is made from finding the derivative of dy with respect to du. Now u is the sort of inside function, and then multiplying that by du dx. So in Leibniz notation, as I explained in the lesson, they split it up two ways, and they substitute the inner function is equal to u. Okay, the inner function is u. Instead of writing the whole function out, they just substitute it for u. And then they start to differentiate the whole thing, first of all, just with respect to u. So that's kind of like do the outside function with leaving u just as u. And then differentiate u with respect to x. So they split it up this way. So what that means is this, that the outside function is this right here. This is the outside function. Okay? It's u to the fourth plus 5u squared. The inside function, that is the u part, is this. It's actually x to the fifth plus 2x squared plus 1. So this is the inside. Okay? So let's just back up a little bit, and like I say, if you find that confusing, this is what y would look like in terms of x. Okay? So when it's not split up, it would look something like this. Watch this. X to the fifth plus 2x squared plus 1 to the power of 4 plus 5 times, what's u? X to the fifth plus 2x squared plus 1 squared. So that's what it looks like. That's the combined, okay, function, which a lot of times we'll just deal with the whole combined function, and we'll do, derivative of the outside times the derivative of the inside, and move on, derivative of the outside times the derivative of the inside, okay? So we can do it all in one step. But in a question like this, they're saying, hey, listen, we've already split up to outside and inside functions. Use kind of Leibniz notation thinking and multiply, do your chain rule this way. Again, when you're first learning, I don't focus on this style of teaching when you're first learning, because I think it's a little more confusing. I think let's just focus on chain rule and, outside function, inside function, chain rule, outside function, inside function. Let's do it all at once with a combined function. That's normally the way I approach it. But it is important for you to know that, hey, this actually right here is u. And this in here, again, is u. So let's do dy du. And that's going to be, watch this. So this is the way they're wanting you to do it. 4u cubed times du dx plus 10u times du dx. Okay. So what is the overall, this technically is dy dx, but whatever. Dy dx now. So what is du dx? That's going to be the derivative of what's inside here. So let's substitute that in now. So 4u cubed. This is going to be 5x to the fourth plus 4x. And that's the same over here. Okay, now actually it says leave your answer in terms of u and of x. So there you go. That's where you stop. And again, okay, this is a textbook question. It does force you to kind of think outside the box, separate the u function and the x terms and everything like that. I believe this is kind of what they want. And they might factor this out, right? They might factor this out, which is fine. So it'd be this right here times 4u cubed plus 10u, whatever. They may factor this a little bit, but this is sort of what they're going for number 2. So if that's a little confusing, maybe I understand that, but I think this is what they're looking for. Let's just double check. So good question, why do we leave u in there? Normally you would not leave u in there at all. You'd have to substitute, because what we're trying to find is du with respect to dx, or dy with respect to dx. Du shouldn't really be in there at all. But it says leave your answer in terms of u and x. So what they're doing, because this is a question early in the assignment, they're trying to guide you halfway through or partway through. And then later questions, they'll get you to finish it right off and then just write things in terms of x. So yeah, we would never actually leave it like this. This is not the end goal here. This is sort of they're trying to progress you through the stages. So yeah. Anyways. All right, so what does that look like compared to solutions in the back there? Anybody look that up? What did they do?
They just factored it.
They did factor it?
Yeah.
So they put the 5x to the fourth plus 4x as a factor and then times 4u cubed plus 10u? Or did they factor the u out and everything?
They have 4u cubed plus 10u and
Yeah.
and then 5x with our plus.
As another factor. Yep, that's fine. So they factored this out like I mentioned, that's fine.
Yeah.
You could also factor a u out, you factor x's out, and you can go quite a bit further, but okay, no, that's good. So does that help with number 2 there? Does that help? Yeah?
Thank you.
All right, you bet. Again, this is not the end goal, and again, I don't really focus on this sort of question because I want to get you right to the very end, and I think, like I say, doing chain rule, without substituting u in there, doing straight chain rule and all that sort of stuff, I think is just as easy. So we quickly kind of move to that. Yes.
When we're doing any sorts of complicated, let's say chain rule,
Yeah.
power rule with chain rule,
Mhm.
those kind of things, how much do we want us to expand in the end? How do we?
How much do I want you to expand in the end when you're, or simplify? Yeah. So that's always, how far do you simplify is always a big question. It is a big question. If you have common factors, you should take them out so that you can eliminate, especially on rational functions. If you have a common factor that you can divide out, you should. So that's why you should factor. Typically, you don't leave negative exponents in the final version. Typically, you would add or subtract, fractions to combine many terms into as few terms as possible. So that's why. You don't have to expand. No, you don't have to expand. Like factored versions are better than expansions. Yeah.
Let's say, for example, in the end, there's a whole big fraction with small fractions inside. Do you want to?
No, fractions within fractions not simplified. No, you can't have a fraction inside of a larger fraction. You have to get rid of those. Yeah. So I guess the best thing to do, I kind of have a comprehensive list of what is exactly the most simplified, but if everything that I've modeled for you in class, or anything that I speak of, like this, right? Like I said, right? This could be factored further. So if you're simplifying this to the simplest form, you should take out a common factor, even of u and x. So this could be factored further. Fractions within fractions, negative exponents, unfactored, expressions. You should deal with all those as best you can.
So if it's
Yeah, the only difference from pre-cal 30 would be, as I say, I'm just saying this again for the video, the radicals in the denominator are typically fine. Those are typically viewed as being simplified. So what I'm saying is if you had 1 over root 2, you could leave it as 1 over root 2, that's simplified in calculus. It's not, you don't have to multiply both sides, but you don't have to rationalize the denominator like we had been doing. You don't have to do that. You can just leave it as 1 over root 2. Okay, does that answer your question about that?
Can I actually show you?
Sure.
So let's say this is what we.
Mm-hmm.
If I'm onto this step, this is not enough. Do I
That wouldn't be completely simplified, probably. No, you'd have to get rid of that negative exponent.
Yeah.
You'd have to factor out a root x
But
there.
by getting the
Oh.
negative exponent, that means I'll have a fraction in the end. Is that what you wanted to say?
Well, you can have a fraction as a factor,
Yeah.
but if you have 2 fractions within a binomial or something, within a, and
No, I'm
they're
saying
just.
if you want me to times it in after I make it into